Mohit. Kanishka, Mohit. Hey, guys. Good morning.
Hey.
Well, I shouldn't have enabled the waiting room, I guess, because that makes people sit there and yeah. All right, one minute. I'm gonna grab the cup of coffee that just brewed. Naveen and Kanishkar, and see if let me ping a couple of other people briefly. And then, Mohit, do you know, I messaged Pratik once or twice, but I'm not. But have you been in touch with him? Do you know if he's inbound?
Yeah, I have been in touch with him over the last few weeks. I haven't touched base with him this weekend or like last few days. I would expect that he would join, but if not, then I can always.
Sure. Yeah, no, very good. Let's see here.
Hey, Durgesh.
Hi.
Okay, very good. Kush said he's going to join as well, but would just be a couple more minutes. So nice. So Durgesh, very good to have you. Durgesh, if you haven't met Mohit before, and actually I guess Kanishkar and Naveen, if you haven't met Mohit before either, Mohit is, well, wears a couple different hats. One of those hats, actually Mohit, do you want to, instead of me.
Yeah. I can just tell. Hey guys, I'm currently working at Symmetric Systems. I used to be at UT Austin as a professor there, and just been generally very interested in the space of container orchestration, just how to build better containers, whether using just Linux-based like SE Linux and so on, or hardware, and then how to use containers for interesting things. So overlaying different things on top of the baseline service mesh, right? So load balancing is great, canary deployments are great, but I think this is just like the tip of the iceberg. We can go like full crazy on this and build really cool systems. But I mean, I've talked with Lee about this a little bit. Without being able to discuss like trade-offs, like keep on adding interesting new features, but if we can't compare performance, like what are you paying for this feature in an intelligent way, it just feels very non-engineering way of doing things. And it's interesting thing is it's very similar to how processor designs were in the late 60s and even 70s. And people cleared it up. Now there's an organization called SPEC, right, that helps you benchmark AMD versus Intel processors, and or even across ARM, so across different instruction sets. So you can build your own mesh however you want, but in the end, we have to come back and report, how does it perform on things, metrics that we all agree on, benchmarks, like for service mesh, like what's the underlying setting? How many machines? How big is the cluster? How is the cluster set up? Like how sensitive, the overall metrics should be to these artifactual things. We just should standardize on it and figure out how to best do it. It's pretty interesting that I mean, GitLab, for example, we've been I'm just kind of going brain dump on kind of why I'm in this meeting and I'm so keen to push forward. GitLab is a super popular open source project, but even that doesn't seem to have published numbers on performance, right? So it's not like you can just import GitLab and run it in a Istio, Envoy, whatever mesh and say what the performance is going to be. It's not even good integration tests for those. So if we can make a plan around this, I'd love to just participate and see how it goes.
Yeah. And so Lidor has joined as well. So very good.
Yeah.
Hey, Lidor, I'm gonna not enable the waiting room ever again. I guess I thought it would be just in case I was late. But so Lidor, Mohit was just kind of introducing to the group here, and so Mohit wears a few different hats, and one of those has been as a professor at UT Austin, and so he's been a champion of the line of thinking that we collectively share around, well, actually it's around a multitude of things, and that there's a couple that ends up that there are a couple of different sub goals, or I guess is one way of thinking about the overarching initiative to measure the performance of a mesh and to do it in a way in which you can, to do it in a way in which isn't just in a vacuum and isn't kind of meaningless. And so we're gonna talk about some of those, but Mohit has been, has had about at various points in time about 3 different of his grad students assisting in advancing the thoughts here and in performing some research. We've presented some of their numbers and some of their research on actually at KubeCon a year ago. I think it was a year ago, and then we're looking at doing it again at KubeCon EU in August. So we've got a spot to talk about some of this. It's precisely what Mohit just described. So in a good way, the thing that I just mentioned is that there's a bit of a time-bound, or some of our efforts here are time-bound to August 16th, I think, is the date of that talk. So that's good to have. It's good to have that venue as well to garner additional interest. I'm gonna jump in and share a few slides, share a few thoughts. The agenda of today was to refresh Mohit, and Pratik Sahu is, some of you guys know him. He's the graduate student that's been the longest standing graduate student that's been focused on this. There are a few things to share and show. One is something that Mohit just mentioned, which is spec.org, which is an organization that tracks standardized tests and standardized benchmarks, and is something that is very much so relevant to our discussion. It's also almost a turnoff to look at, because it just feels like 1960s, 1970s, or what have you. And I think, anyway, that's actually one of the points of conversation, is that of what we're doing here, there is the need to establish something of a working group on this, so that we can be better organized, have a bit of a cadence to these discussions. And we've just begun to establish individual working groups in context of the Layer 5 community and focused on meshery. But I wonder, and so I consider that whether we're ready or not, we need to start a working group on this topic to really advance through these things. We're going to be doing some of this work anyway. We may as well have a home base for it. Part of the open question for where that home base should be is whether or not to host that working group in context of the CNCF, and that might be the right thing to do. And speaking of the CNCF, Meshery itself, and then this service mesh performance specification are both intended to head into the CNCF this year, or minimally at least Meshery. So Pratik is with us as well, and Pratik is familiar with, I think he's on, Pratik, you're on audio now, right? Or no, not yet. Pratik.
Hey, sorry.
Hey, no, thanks for jumping on. You may not have gotten advanced notice, so it's good to have you. Pratik, you're familiar with some of the folks here, and I'm not sure if you've met Mohit before, but he's with us on the. Anyway, I was blathering on. The objective of a couple of things that I wanted to do is, one, we're starting to create some working groups in the Layer 5 community. We need to establish a cadence, and we've got enough interest, enough talent just on this call alone to come to bear on these. And this really is a fraction of the amount of people that I expect will at some point weigh in on this spec, and weigh in on this benchmark. And actually, as I say spec and benchmark, it's like, well, okay, well, what are you talking about? What's the scope of the things that we're trying to accomplish? And I'll articulate that from my perspective, but that's not a set in stone thing necessarily. I'll say it by maybe starting here with this service mesh performance specification. It is essentially a YAML file at the moment, so which is intended to be a standardized way. I mean, standard is a big word, but anyway, it's intended to be a standard format in which you would describe the type of performance test you're going to run, like how much load you're going to generate, for how long, at what rate, and for how many load generators you're going to have, and that kind of thing. It would also describe your environment. How big is your cluster? How many nodes and CPUs and memory and et cetera do you have? What all do you have deployed? What type of app do you have deployed? It would capture the results of the performance test. And it also captures kind of the configuration of the service mesh, its version and how it's configured, what all it's doing. We intend to, from that spec, hopefully introduce some kind of a concept like I'm not sure if there's a more clever name at the moment, but something of a mesh dex, if you will, as a simple way of referring to, of having a simple scale that lets people say, hey, I'm running at a mesh dex of 90, and that's great, because this is how much value I'm getting out of the mesh because it's doing this many things, or that's horrible because there's so much overhead here and I'm really not getting that much value. And so to give people, to give all the rest of us humans something easy to understand and an easy scale to measure, but there needs to be a formula behind how you calculate mesh dex. And so I know I've spoken with each of you, I think, about this particular concept. There's some prior art as to what I mean by a simple scale and how it provides value. And that prior art is something called AppDex. It also looks like it's from the 90s, or not the 60s, but maybe more the 90s, which I think it is. And if you go look, you can kind of read through, it's relatively simple formula that it uses. And in some respects, it's subjective metrics. It's good to take inspiration from and think about how it is that a mesh dex formula would be created. I don't have these answers. I mean, this is, and I'm kind of quickly trying to go through what it is I think that we're going to try to accomplish. So part of accomplishing this has been that if you go do a Google search, or go do a search for comparing the performance of one mesh to the next, you'll find a number of articles out there. And hats off to those that have taken the time to do this and publish the results. it's not easy. The people typically end up building bespoke tooling or hobbling together a set of tools to do that test. Meshery is intended, in one of its feature areas, intended to be an easy to use tool to perform those tests. We've got an agreement with the CNCF to use, I think the agreement was 20 something nodes at the time, physical machines in a pristine environment to go run sort of point in time, authoritative, if you will, analysis. Oops. The Meshery itself, and this is part of today's agenda, is to do a quick kind of update for, I think for all of us to kind of be on the same page about Meshery's current functionality in terms of performance analysis. But one of the things that Meshery does is collect performance results. So you'll notice on either meshery.io or the Layer 5 site that this number is real time. If you go run a performance test now, you'll see this number hike up. And so we're trying to collect performance test results so that at some point we've got a statistically significant set of numbers to go do some analysis on. My gut tells me that the useful numbers, the useful number of tests that have been run within here are way lower than this number. Either people are just running some sample silly test that isn't of value, or some of these results were collected before we actually pulled in all of the environment information and kept that as well. And I think without some of that context, not all of these results are useful in an analysis, but so we'll see. There's a folder that each of you, I think, have access to that has some materials, some longer write-ups about what we think we're trying to accomplish, about doing a benchmark, about establishing a spec that I was talking about earlier, about establishing a mesh DEX. Lastly, that part of our, it's not actually not lastly, there's two other things. I guess I'll come back to this. Today, and we'll see this hopefully demoed here in a moment, Meshery has support for 2 different load generators, but we're considering a third. And when we do, we're considering that third would be a load generator that you could have many instances of and generate load in a distributed fashion. Kind of interesting to me that we have a bunch of distributed systems, and maybe I'm just unaware of it and haven't searched enough, but I don't know that I've heard a lot about distributed performance testing. So there may be some interesting things for us to glean as a community about that. So one of the last thing that part of the goals here is, and I've conversed with each of the service mesh makers about the use of Meshery in their environments, in their build and release process, to have Meshery help them baseline from a release to release, from a build to build perspective, their performance, and to run certain types of tests in various configurations. Meshery's just kind of gotten to the point where I think that we're ready to engage there and ready for some of those people to begin running it. My hunch is HashiCorp might be the first ones to pick it up. I don't know. I say that not because the other ones aren't amenable to it, just because they keep showing up and trying to partner as much as they do. And once one of them does it, like, the other ones are going to feel a lot of pressure. So there's another related initiative that helps build my confidence that that Meshery would ultimately be incorporated into those build processes. One is that Meshery, when it heads into the CNCF, that will make everyone feel good, I think, be comfortable, recognized as sort of the tool to use. 2, that Meshery is positioned to be the conformance tool for service mesh interface. Service mesh interface is another open specification that was recently adopted into the CNCF. And as Meshery goes to be that tool, well, and if Meshery is, that reinforces the notion that each of those build and release teams of each of the service mesh makers that they may want to have Meshery running to confirm their compliance with SMI and to continue to baseline the performance of their mesh. And so we're getting together today sort of in advance of kind of establishing a working group. Maybe that, I think in some respects, this is kind of, this is sort of that first meeting, if you will. We need to wrap a bunch more structure around it to help it move forward. Maybe that working group needs to happen in the CNCF. I said that earlier. And so with that, I'm going to step back and be quiet, say that we can walk through a demo, but comments here. Very late last night, I had invited a couple of Googlers, or the Istio performance team lead, to join, in part, for him to join and for one of his employees as well. I sent that to them extremely late. You know, I didn't expect that they would join it. That's fine. But they've participated in the past.
Oh, is there a standard way that the Istio guys like to report their results? Do they report it on like Bookinfo app and stuff, or?
Yeah, they just now, not just now, they in the last couple of months have begun to have a bit more of a dashboard for how it is that they're surfacing results. And so to answer your question, we've had a little bit of a hard time. We've talked to them a number of times about what the specific test configurations are and making sure that the Istio or Meshery is able to accommodate those. And
I just shared a link of Istio's performance results that they have shared on their webpage. They have a couple of benchmarking tools that they use, a couple of apps, and what kind of latency, connections, throughput graphs they have run on baseline and with various of their service mesh features. I mean, that is one that they have openly shared. I'm not sure if Lee has some insider info on that.
Yeah, I can't figure out where I'm looking at the chat, but I don't, oh, the chat in Slack. Yeah, very good.
Yeah, yes, sorry.
So this is one of the things that we need to go follow up with them and ask them for specific test configurations. We've been on any number of calls with both Google and IBM for Istio specific, you know, for the tests they run for Istio specifically, that they go on, some of those tests go on for miles of spreadsheets, because there's lots of different configurations to do. They've said, I think, you know, Mondar Jog is the name of the test lead for Istio at Google, and has shown the most interest here. We need to, get, like he said, like there's like 3 that are probably critical to them in terms that they would want to have make sure Meshery was testing. And I think between all of us being busy, we're just not sort of following up and making sure that we're getting that described. He had hired in an engineer, Carolyn is her first name. They have since put together a bit of a dashboard. And I don't know if it's linked here. I would assume so. One of the things that we need to, that would be good for us to have is Meshery listed in their, here in this repo under Istio tools, the performance section. I think we would probably find a link to the dashboard. Yeah. Anyway, this is, I think it has only been because of COVID, for the most part, that I've been in, that is so many, the community has been scaling and scaling, that I think that we're to a point by which, if we go to, I think we've had a couple of false starts with engaging with the Istio team because we haven't had enough time. But the formation of a working group, a bit of structure with a cadence to meetings, a mailing list, a Slack channel, etc., recorded meetings, maybe bringing that into CNCF and having those meetings kind of in context of that might encourage some of that participation. And so one of the things, the action items I'm going to take away is probably to introduce all of you to all of the rest of you, or to kind of get a mailing list together. And this was sort of Mohit had in a good way said, hey, we should probably refresh on where we're at. And so hence this meeting, but we need to establish a cadence.
Okay. I think there are some of the questions that I think at least these tests don't seem to hit at. These tests, meaning the Istio tests, or a bunch of others that I've seen, is they will micro benchmark a proxy by itself. So if you scroll all the way down, I think there's some, maybe there's some other link I followed off of here. Basically, let me put it on. Yeah, I mean, I just followed the link that Pratik sent and kind of clicking around.
Sure, yeah.
On micro benchmarking the storage proxy, yeah, stuff like that, right? Where you're just looking at, latency added by just this thing, but what it's missing is a lot of context, which is what's the effect on end-to-end workload? Like, is this even going to show up on end-to-end workloads versus not, right? And B, especially for the control plane, what if I want to do interesting, more aggressive control plane policies, right? So what's the effect of, so I don't just want to have a static workload and just see what can I push through the data plane proxy. So to me, that's one interesting, useful case, but not all of it. So benchmarking interesting control plane ideas, and even for the data plane, a lot of the interesting use cases for Envoy, for example, are adding more filters for traffic, right? So, adding whether it's like layer 4, but also like application layer filters into the logic. So now how would the overhead scale? And now if you have like a system that is dynamic, so it's not just like, okay, I have these 3 boxes worth of a few containers kind of set up, right? If you want to scale this up and down, what does it do to the overall system performance / responsiveness? So I think just establishing that would be really interesting. And it could be done with, I think like Istio guys do it for like few servers. I posted another link from a different provider of Kubernetes services. Like they had like a small cluster with 2 or 3 machines. So just kind of settling down like, hey, talking to a median HashiCorp deployment is this big, right? Or a median Istio deployment across, whoever they know about is this big. And maybe like a small, medium, large kind of setups with different types of like how, like put the control plane to work, for example, right? Not just push traffic through the data plane proxy and report, 3 milliseconds, everything's great. Obviously, if we do very little work, just pushing things through a vanilla null proxy would be pretty low overhead. But that's not where the service mesh's big use cases are, right? You want to add more data plane functionality, and I don't want to spin up a separate sidecar for every new thing I want to try. I want them to be added as filters, for example, into Envoy, right? So I think like that's the kind of setup. I mean, so in our lab, there's another student who's looking at, deploying n-versioned execution inside a service mesh. So you have like multiple copies. So if there's like a flaw or an exploit in one, you sort of always, it's slightly different than mirroring, meaning you send the traffic out, but you also check the results before going out, before sending the result out. Right? So it's not like the copies outputs are dropped by default. So there's like a bunch more extra work being done inside the mesh than like a really simple vanilla data plane proxy. Yeah. But yeah, so I think like these are the type of use cases. One of the things I was thinking is, would it help if we pull in some existing open source project as an end-to-end test? I mean, GitLab is a good example, or Elastic or something like that, where let's run one of these things in a mesh and then apply a bunch of different interesting control data plane policies on it, right? Because if the workloads are going to dominate, then why do I even care about shaving another millisecond off of the data plane proxy?
Right. Yeah, that's good. For my part, I consider so part of what makes these tests or some of the results uninteresting, or part of what might make Meshery as a tool interesting to others, is that it's a tool to help facilitate tests on your workloads. So one, that's interesting. But then two, that your workloads are so much more interesting than Book Info or than Emoji Photo or the whatever sample app that. And that, I think if we're going to discover truly interesting things, it probably is in context of a GitLab or of an actual.
I mean, GitLab, for example, sounds like a reasonable median, at least a very popular workload, right? Or Elastic. I pick a different one, like Elasticsearch Stack or something. I'm not married to any one of these, but it seems like it would be worthwhile because a lot of people deploy Elastic, GitLab, etc.
So we did, and on that actually, we had a couple of conversations with Christina Delamitriou of Cornell, and tried to use the
bench.
Yeah, and found that it was hard coded to Docker, and so tried to help get them to bring it into Kubernetes and ultimately we spent a fair bit of time. We ultimately did. I think it now is Kubernetes compatible. It's just that we never really, I don't know if it's her personality or what happened, we never really got traction there. That doesn't mean that those workloads aren't necessarily meaningful. But actually something like a GitLab, actually, since almost, most of those looking at the results would be
familiar with those.
Yeah, that's a bit more compelling because I agree too that what excites me in particular, and I know a couple of other folks on the call, Kanishkar as an example, is in fact just what Mohit is saying, which is those application level filters that you can through WASM, more or less, that you would put into your. I mean, we're getting technology specific, I guess, but put into Envoy and through WebAssembly. We are on the list to present. Well, we were on the list to present that at DockerCon this coming month. I've pulled this off, and we're going to do it separately as a separate Docker hosted thing. But my point is, we're not for lack of any venue to get the word out or to publish these results. It is the most interesting about those filters and what they can do, because in some respects, there's enough prior art out there that talk about the effects of the control plane, the effects on the data plane but not necessarily the effects of using these layer 7 filters, or the effects of doing that in this workload that is a meaningful workload that everyone kind of understands. Do you, Mohit, did you guys have of the environment that's at UT Austin? Do you guys have an app deployed now? Something that's significant?
Yeah, so we, I think Prateek knows even better, but I think we have GitLab. We've been using that a lot. I don't think we have deployed Elastic. I mean, we have deployed Elastic. I mean, Elastic is easy to deploy, but I don't think we have experimented with putting actual data into it and scaling it up and down much.
Yeah, we have been experimenting with GitLab and a couple of smaller sample applications from Istio. Definitely, there are a couple of applications which we just use for security testing, like the damn vulnerable web app, and trying to have application port them into service mesh and try to see things like what Mohit was mentioning. One of my colleague who was working on the inversioning, he has ported the damn vulnerable web app. Uh, Elastic is a good example. We have not ported that. I think one of my seniors has also tried to tweak around a couple of Death Star bench applications in Kubernetes, not specifically service meshes, but a couple of the Death Star bench application in Kubernetes.
So there's okay. I should probably be trying to take some notes here, because there is kind of a thread that we have about identification and sort of selection identification of the right workloads, or the right, or interesting, I guess, entry.
I think, I mean, GitLab just seems easy. You know, it's like it's super easy to create it.
Is it nice? Yeah, yeah.
And Mattermost is another one, but I guess it's a little less popular than GitLab. And if you want to set up Elastic, and that sounds pretty reasonable.
We can also look into a couple of fast workloads to put into service mesh. And of course, the Istio folks and the IBM folks use the Blueperf, the Acme Air application, as a sample application, which is like a airline reservation type of application.
And Mohit or Pratik, remind me, that one's open source, right?
Acme Air, yes.
Okay. Oh, okay.
The Blueperf / Acme Air is on GitHub. I'll just post the link on Slack for general visibility.
One thing that would be good to air out on this call and get Pratik and Mohit and Lidor and others that haven't talked about it just yet thinking on is, well, is a GSOC project that we have pending for incorporation of, well, potentially of testing tool that Envoy uses called Nighthawk. And so Kush has been giving some consideration here about either incorporating Nighthawk or Vegeta as load generators that are capable of being distributed or deployed in a distributed fashion. So Kush, do you want to, I'm going to try to grab the link to your design spec, but this would be something good to explore here, because I wonder, just with that brief description, well, I'll say this, that there are some tests that people run where they generate load from outside. Thank you, Kush. They generate load from outside of the cluster. There are other tests that people run where they generate load from inside the cluster. I think almost any test configuration is valid. I think some test configurations are not very meaningful, while others are extraordinarily meaningful. And in part to Mohit's point about like what workload you're using, it's like, well, hey, it is valid to use a very simple app that, you know, that's such a lightweight workload that, you know, it's a valid test, but what's really meaningful is when you've got a big workload like GitLab. And I guess what I'm trying to ask is, do you guys consider that if the Meshry as a project facilitates deployment of a number of of instances of a load generator, and are going to start hitting on, like maybe GitLab as an example, hitting on various endpoints at the same time, that like that type of analysis, that type of research is interesting. Because what I generally see is people doing testing, selecting one, and that's what Meshery does today, is one endpoint, one load generator, and tries to hammer on it from there. And it's good to have control, I think. You introduce additional variables and it gets harder, but it seems like it's a valid test case to have multiple load generators hitting on multiple, either the same endpoint or multiple endpoints. And that's kind of what this spec is about.
I think, yeah, it is interesting to see if there are any bottlenecks that come into picture if we are hitting from multiple endpoints, like if one particular load generator is already pushing the server which is serving the request to its limits, then a multiple endpoint generator might not do much good. But if the bottleneck is from the client side and the client is not able to generate a request which is pushing the server to its extremes, then it might be helpful to have a distributed load generator so that we are pushing the server to its limit, because we are trying to benchmark the service server which is providing us the service. But I think the main goal is to push the server to its limits for getting nice numbers and making some good observations.
Yeah. I wonder, like, in the real world, you're running a service and you've got people from any different geographical location hitting on your services. Is use of distributed load generators in that context interesting?
Uh,
I don't know if it is. It may not be.
So yeah, I mean, it is definitely in a sense, like when you're saying from different geographical locations, I mean, there are obviously a lot of network delays that you incur if you are trying to hit a service from a different geographical location, like say a European server from US or something of that sort. Uh, uh, all of those are mostly network latencies. Like I don't see a clear picture where service mesh brings in a functionality that is going to help with this. But if it does, then yeah, then it is definitely like if there is like a jump proxy that we can configure using service mesh or something, but I'm not sure if that is true. Like,
Or maybe if there's different, so sometimes people, I think someone was asking this question in the Slack channel here recently, was like, can you, for Istio specifically, it has ingress gateways and egress gateways. You could imagine that having a single ingress gateway could be a bottleneck potentially to for traffic getting into the mesh. So, okay, so people might deploy multiple ingress gateways. And to the extent that they do, maybe that makes for an interesting scenario for distributed performance, or having multiple load generators, either one per ingress. I don't know. I mean, yeah. Does that just make the scale the numbers higher and make all the numbers higher in terms of the tests, or does that have an effect on how the system works?
I agree. Like in such a scenario, it would be helpful. So that is again, if we have multiple ingress gateways and configuring just one gateway is like if we can configure multiple ingress gateways, and suppose with just one gateway we can serve 700 requests, but with like 7 gateways we can service 3500 requests, then that is a valid scenario where we are pushing the service to the limit with multiple of ingress gateways, and in that case distributed load generator definitely makes sense.
Yeah, okay. Okay, good. That's good feedback. What do you guys think if we do a quick recap of Meshery's capabilities? Would that be helpful?
Lee, just wanted to ask actually, the last updated invite that I got was actually on Google Meet. So I'm not sure. So when did this edit, like when did this change to Zoom meeting?
Oh no.
Is it?
Yeah. Yeah. That's too bad. You didn't see anyone else on the Google Meet, did you?
So I actually was there for the past 20-25 minutes because I was just hoping that it would start. Was in on I received an invite, like a updated invite on 25th, and it had the link of Google Meet.
Damn it. Yeah, I apologize. I had moved when, yeah. Yeah, I'm sorry. I think when I originally scheduled the meeting, it was on one Google Calendar, and I just switched it to the other Google Calendar, and in the process of it switching, it automatically added a Google Meet, which I didn't realize. Yeah. Oh. So thanks for coming, Shivai. Sorry. Okay. So yeah, I'm sorry, Shivai. We are recording. Not that I can spend some time and catch you up because.
Okay, sure.
All right. So briefly, I think this is may or may not be helpful to Lidor as well. Not all of us have actually necessarily seen Meshery connected to Grafana or to Prometheus as well. Let me stop sharing my browser and just share my desktop so we can kind of switch, open up the terminal here as well. All right, so all right, quick demo of Meshery. How do we do this? So we've got, I'm running on my machine here. It's a Mac. I'm not running Meshery. Meshery's configuration that I'm running is really just the standard one. It's got Meshery server and then individual adapters for individual service meshes. When I do a Meshery CTL start, that brings up Meshery in my browser. I'm running Docker desktop, and inside of Docker desktop, Kubernetes, an instance of Kubernetes is running. I've used Meshery to deploy Istio 1.5 with MTLS. I've used Meshery to deploy a sample app, Book Info. And so Mohit, by the way, and Pratik, as we think about sample apps, there's a few different ones supported. This one I'll call out just because it may or may not be robust enough to be of interest. I think it's kind of on the order of Weave's Socks Shop, but this one is Google Hipster Shop. So
do these apps come with the representative like sessions and inputs and this sort of stuff?
Oh, wait, ask it again.
Do these apps also include like a representative set of inputs driving the apps?
Oh, no, not to my knowledge. No, none of them.
No. The Book Info application has just one input. The HTTP bin application has a few diverse inputs, like we can have a JPEG, PNG, or a database kind of small database kind of inputs, or some null inputs. The HTTP bin has a couple of diverse endpoints from a small load to a high load. The hipster one is something new to me, so I can quickly look into the hipster.
And then Good question, Mohit. Yeah, to my knowledge, none of them inherently drive workload to themselves, which is where we spend time in Meshery then generating workload. So I'm just configuring this environment to have, so there's an Istio deployment on my system. Istio can come with Grafana and Prometheus embedded. And so I'm just telling Meshery to connect to both that Grafana and that Prometheus instance. You can, right now, my Meshery is only configured to talk to Grafana, and that's actually enough to pull in a bunch of Grafana defined charts. So Istio, for example, ships with this Grafana instance and then some predefined dashboards that if we were to go look, here there's a few boards. Each of these boards have panels, and the vernacular that I'm using is that of Grafana. And each panel has, any number of metrics. So this vCPUs one has 4 metrics that are tracking the vCPU for each of those processes. When you go into Meshery and you connect Grafana or Prometheus, right now, Meshery is only connected to Grafana. So it's connected here. We just kind of do a quick test to see if we can talk to Grafana. We can. These same boards that you're seeing in Grafana, they show up here in Meshery. So I'll just choose the same one for, in here, these are I want to use the right term. These are the panels that we were just looking at. There's actually 4 of them called vCPU. So I'm going to just choose those 4 because I think some of them will have statistics and some of them won't. So the one that we were just looking at, I think is this one here. There hasn't been any load. Yeah, it is, because these are the same 4 Istio control plane components that basically have 0 vCPUs being used, because it's not doing anything, it's not serving any load. But so once you've chosen to add something like that board, it will now show up when you go do a performance test. You don't actually have to connect to Prometheus to have those statistics show up. You can, I'm going to only for purposes of demonstrating that to help open everyone's mind to think about the potential need that it basically, if you've got a need to pull a metric from a Prometheus instance that maybe it's a daemon set that you're running on the cluster and it's looking at node resources or whatever it's looking at, that, or maybe the workloads that we would be monitoring, like GitLab, might have metrics exposed that are Prometheus compatible that maybe we would want to pull. Anyway, so now that it's connected up, you could go and do a test. Oops. As we load up this performance test interface, it starts to load up that same set of charts that we had said that we want to look at. So Meshery understands that we've deployed Istio. It has yet to understand that we've deployed other workloads. I think that we have. At some point, it'll get much better so that it will just identify all the endpoints that are available and make that testing easier. So I take it back. I didn't deploy book info, but I'll do that now. If we just get the pods of the default namespace, you can see book info is being deployed, and soon it should be ready enough to call out to So here's, I don't think all of the app is up just yet. It doesn't really matter. But we've got the endpoint that we can hit and generate load against. And generate load for 10 seconds. We are giving people right now the choice of which type of load generator they want to use. the behavior of the behavior is fairly similar of these, but they're, the way that
pick like one endpoint at a time to generate load to?
say right now it only generates load against a single endpoint at a time. Is that what you're, yeah. But that, I think that's in part something to be addressed with like the distributed performance testing, that, hey, maybe you'd want to do that across a bunch. You wouldn't have to have multiple load generators to do that. We could facilitate for, like right now it's saying how many threads or how many processes do you want to spin up of using a single instance of Fortail, how many threads do you want it to have to, so maybe dedicate one thread. I think there's a number more nerd knobs, if you will, that need to be identified, like, hey, on a per endpoint basis, how many threads did you want to run? The ability to save these configs and schedule them as well, probably helpful. That between, irrespective of which one you use, you'll get the same user experience, that it'll show you that it's running. You can navigate to elsewhere in the UI and it's fine. It'll tell you that, you know, your test results are ready for viewing. It'll show you what those look like. We need to enhance the way in which the metrics are delivered, because it's a bunch of stats. What we see now is that the Grafana board, the panels that we pulled in are much more interesting because we've got load generated against them. We see that the proxy was doing a fair bit of heavy lifting compared, the data plane was doing more lifting compared to the, actually I take it back. I don't think that, yeah, no, I guess that is the data plane. So, in order to support that spec that we've been talking about, oh, thank you, Lidor. Yeah, very good. Very good to have.
Yeah, thank you very much for now. Yeah, I'm more like to what you are doing, you know, to get some insights about the process, and yeah, I will come with your questions later for the next session. So I was a bit quiet now, just to want to see what you're doing.
We got big expectations of you, by the way.
Thank you. Yeah. I need to reorganize myself and then to see what I will ask for next time, or I will write you back in the Slack channel. Oh,
very good. We'll talk to you very soon.
For now.
Yeah.
Yeah. Have a very nice day. Bye-bye.
You too. Bye. Last thing I think to kind of demo here is just the notion that users can go ahead and download their test results. These test results are shown in that service mesh performance specification format, that spec format. But right now it's only a partial implementation. Like Naveen, who's on the call, he's working with another contributor, VJ, on trying to get this fully flushed out so that all the statistics are there in the same spec format. I know everybody's got to go. We got a minute left. The last thing that this does is persists your results. It'll also try to grab your node CPU and memory utilization as a standard thing to grab with every test, because that's important to understand what was going on your nodes. And then, yeah, and then lastly, let you compare two different tests and how they performed. And so yeah, that's the collective kind of things that Mesh does. Yeah.
Hey, Lee, I have to jump off as well into a different meeting. I'll follow up with you afterwards. I think this was really helpful to just see where things are at. And I've talked with Pratik as well, but I'll follow up over Slack.
Good. Yeah, thank you, Mohit. Yeah. See you soon.
See you. Bye.
See you.
See you.
So I know we should try to end on time, and people have got to go. Good. This is a successful call for me. I don't know if all of you have seen all of what I've just shown in the past. Some of it needs to be bubbled up in the UI to make it a bit easier to get to. Some of you are actually working on solving that. I'd like for us to, I'm going to send out a poll to everyone to ask when a convenient sort of ongoing time to meet is, or to have kind of a regular touch point to outline the goals a bit better, and you know, to basically get us going. I'm assuming we might get more participation from some of the service meshes if, I guess I have a mind to bubble this up inside of the CNCF SIG network and tell people broadly that we're established and there's a working group and we're going to do this. But yeah, that's it. So that's, anybody else have any comments before we close?
Just one thing to say. So this is way beyond my dreams. This is way beyond my dreams, to be honest with you, because like the way things in my university is that most of my seniors working in the industry are just working as support engineers. They have no idea of this. They have no idea of this, and it's like off the roof. I'm trying to get a hold on it and work on it, but as of now, my semester is about to get over. In May 11th, I'll be done with this. I can like put my mind and work on this.
Yeah, that's all.
Thank you, but I'm very grateful for this opportunity to work with you. I mean, I can't express it.
That's good. Yeah, it's gonna take your help, Durgesh, because the other guys on the call will tell you that I'm stretched a bit thin, and it's not that I'm any smarter than any of the rest. It was never up to me to actually do this anyway. So,
I mean, it's like most of the time the way things work is that people just come here, go take an internship, get a job. That's it, you're done. So it's like this has like opened up my insight into a different level. And most of my seniors, when I like told them that I was working on service meshes, they had no idea. Especially there was one of the guys who was in Amazon. He was, okay, that's nice. And my professor even complimented that Kubernetes is going to be the way to go. So catch hold of this. I can't like express that, but I'm very grateful.
Yeah. We're ahead of the curve, I would say, in terms of just service meshes themselves. So, so get in early, I guess. Get in. Okay, very, very good. Yes, thank you for that, Durgesh. Anybody?
Lee, I'll catch up with you. Like what me and Mohit have been discussing on the research front. So I'll catch up with you. It's already 12:30 plus, so I don't want to be going overboard. And it is not important discussion point anyways. So.
Good. Okay. Thank you all for being on. Some of you, your works are being called out, very much so. We'll have your name in lights soon, I think. Okay. All right. Thanks, guys. We'll talk to all of you very soon.
Thank you, Lee. Bye.